I am Anil Kumar. Welcome to my series on exponential functions exam review. The key word here is exam review. The whole idea of this series is to work in a fashion so that we can get maximum marks in examination in the least amount of time. So my focus here will be to work on very important aspects which sometimes are overlooked. So I hope this series will be very useful for most of the students who want to really score very good marks and also get good command on the subject itself. So we'll discuss exponential functions. We'll see what are the characteristics of exponential functions. We'll understand how to work with exponential equation. We'll look into transformation. We'll see how to write graph of an exponential equation, how to write equation from the graph of an exponential function, and then we'll take up an example based on exponential modeling. In the next video, we'll talk about logarithmic functions. So these are very important topics to understand exponential functions. When I say exponential functions, it means we're talking about y equals to a to the power of x as our function. Now in this particular function, a is the base and x is the power or exponent. In the language of functions, x is your input and y is the output, right? So that is what it is. As you know, in this particular function, the domain is not restricted. Domain is x belongs to real numbers. There is no restriction on the domain. As far as the range is concerned, we know that y belongs to real numbers, but y should be greater than 0. The idea is that in any exponential function, we have a horizontal asymptote, and if the value of a is greater than 1, then the graph is increasing. So that is when the value of a is greater than 1. However, if the value of a is between 0 and 1, in that case the graph is decreasing, right? So this is the case when a is greater than 0 but is less than 1. But always the graph of the function will go through the point which is 0, 1, right? So the y-intercept will be at 0. Is that clear to you? So this is the exponential function which we are talking about. An important thing to note here is that we do have a restriction. And what is restricted is basically a is restricted, right? So the base a is restricted. So whenever we talk about restriction of an exponential function, it is this base which is restricted. It is never negative, right? So we know that the base a is greater than 0 and a is not equal to 1. Correct? Now the question for you is why it is so. So this is what you should answer. Why? Perfect. Now let's look into the characteristics in more details. So we'll now again talk about the characteristics of exponential functions. I already have two graphs here shown. The parent function, as we have just seen, is written as y equals to a to the power of x, where a is greater than 0 and is not equal to 1. Why it is so? That is what you should be answering. Now let's list the characteristics. So general properties, as you can see here, is that we always have a horizontal asymptote. And the equation is y equals to 0. So the x-axis is the horizontal asymptote. Now, what is horizontal asymptote? That could be a question sometimes. So we look into what happens when x approaches positive infinity or when x approaches negative infinity. So those are extremely large values. And if in any case y approaches a fixed value L, then we have a horizontal asymptote which is y equals to L. So that is how horizontal asymptote is defined. So in our case, for the parent function, the x-axis itself is the horizontal asymptote. So that clearly indicates that for a given function, if I have to write the domain, you can see from the graph that there is no restriction x belongs to real numbers. However, as far as the range is concerned, it is always above the horizontal asymptote, right? So the y value belongs to real numbers, but y value is greater than 0 for the parent function a to the power of x. Clear? Now, another important thing to consider is that if a is greater than 1, then the graph is increasing. You can also say positive gradient or gradient is positive. But if a is between 0 and 1, in that case we have a decreasing graph or negative gradient. Correct? Now, we have two graphs here. Can you tell me what could be the possible equation of the green graph? Well, we know all the values will go through 1. To find a possible equation, it is a good idea to look into the value of the function when x is 1. So when x is 1, in this particular case, we have the value which is 3. So that clearly means that the graph is y equals to 3 to the power of x. On the other side also, just to maintain the symmetry, we have the value of 3 at minus 1. And we know that the graph is decreasing, correct? So in this case, the function could be written as y equals to 3 to the power of minus x, or you could also write this as y equals to 1 over 3 to the power of x. Correct? So that is the decreasing graph which we had been talking about. Is that clear to you? Perfect. With this, we know whenever we are looking into a graph of an exponential function, what are the key points? Clearly, the key points for us are, let's list them. One is the horizontal asymptote, which is always y equals to 0. Then we have the y-intercept, which is at 0, the value is 1. The third one is that the graph is either increasing or decreasing. And then we can also say that the value at x equals to 1 is the base itself. And at x equals to minus 1, the value is 1 over a. So that gives you few important points. The horizontal asymptote can also be considered as an end behavior. Is that clear? End behavior, let me write again here. Horizontal asymptote is when, rather we have written here, x approaches positive or negative infinity, correct? So one side it goes to infinitely large value, the other side it approaches 0. So you have the end behavior defined. If the end behavior is approaching a value, then we have a horizontal asymptote. Perfect. Now the question remains, why a is not equal to 1? Well, if a is 1, then what happens? If a is 1, if a equals to 1, we have a constant function. Then the graph will be kind of a line like this, horizontal line. This is y equals to a. Perfect. It is not an exponential function. It is not increasing or decreasing. Perfect. So the exponential function, it is kind of important to understand that it is always increasing or always decreasing in its entire domain. And the domain has no restriction. Perfect. So that is how you have to look at an exponential function. Now let's move forward and see. Let's work with exponential equation. So I have a very interesting example here. The question here is, sketch graph of y equals to, let me rewrite this equation here, y equals to 2 times 3 to the power of x minus 18. Show that horizontal asymptote and the coordinates of points where the graph crosses x and y axis. Show the horizontal asymptote. So we have to show all these points. Write domain and range of the function. So what we expect from you here is to find the points and then sketch the graph, right? Okay. So let's work with the horizontal asymptote first. As far as horizontal asymptote is concerned, when we are given this function, we can say what happens when x approaches negative infinity. In that case, 3 to the power of x will approach 0, right? Anything to the power of negative infinity. Or we can say 2 times 3 to the power of x will approach 0 and y will approach minus 18. Now, minus 18 is a fixed value, right? And therefore, we have a horizontal asymptote whose equation is y equals to minus 18. Is that clear to you? So this is how we actually get the value of horizontal asymptote, the equation for horizontal asymptote. Correct? Now let's look into the second point, which is the coordinates of the points where the graph crosses the x and y axis. So let's talk about x-axis first. Okay, so x-axis, which is x-intercept. So we're talking about x-intercept now. X-intercept means y equals to 0. So if I substitute y equals to 0 in the equation, what do I get? I get 2 times 3 to the power of x minus 18. We can now solve for x. So we can write this as 2 times 3 to the power of x is equal to 18. 3 to the power of x is 18 divided by 2, which is 9. And as you know, 9 is 3 square. So comparing, we get x equals to 2. So we have the x-intercept, which is at 2, correct? Or you can write the point 2, 0. Now, let's look into y-intercept, which is when the graph crosses the y-axis. So when we say y-intercept, it means what? Y-intercept means that x value is equal to 0. Substituting 0 here, we get the y value, the y-intercept, which is 2, 3 to the power of 0 minus 18. Anything to the power of 0 is 1. And so we get 2 minus 18, which is minus 16. So we have the y-intercept whose value is at 0 value of x, the y value is minus 16. So we have our critical points. We have the horizontal asymptote, we have the x-intercept and the y-intercept. Now, we also know since the value of a is greater than 1, it is increasing, correct? So we are now looking for increasing function. So let me sketch the function here. So we'll begin with the horizontal asymptote, which is at minus 18. So let's say this is the horizontal asymptote. Let me write this as y equals to minus 18. The function is increasing. Let me write down increasing function. Since the a value is greater than 1, correct? We know the y-intercept. Let's say this is the y-intercept of minus 16. And the x-intercept is at 2, let's say somewhere there, and it's increasing. So we can sketch the graph very easily now from these parameters. We can say this is the graph for the function. Exponential function, always increasing with horizontal asymptote, the vertical, the y-intercept, which is at minus 16, and the x-intercept, which is at 2. Does make sense to you? These parameters are enough to sketch exponential function. Perfect. So as we were talking about, let's get back to that. We had decided that we need to find what horizontal asymptote is, which is also the end behavior, the intercepts, increasing, decreasing behavior, and a critical point. What happens when x is 1 or minus 1, correct? So those are also very important points to consider. You can always place those values, calculate and figure them out. However, these are good enough to sketch a graph, right? So the clear key word here is sketch. So let us try to understand these words also. So when I say sketch, the other word is graph. Graph has to be very accurate. Now, from examination point of view, it is a very important distinction. So I like to highlight once again, since the question is sketch, we didn't really get into a lot of other values. These were good enough for us to get graph, which is good enough for this particular question. Perfect. Now let's look into the next example. The question is based on transformation of exponential equation. Well, we have considered the same equation. Sketch the graph of y equals to 2 times 3 to the power of x minus 18, but this time use the concept of transformations. That is the difference. The idea is that we have to understand the concepts and how to approach to solve a question, right? That's the key. So let's talk about the transformations for a moment. We have the equation which is y equals to 2 times 3 to the power of x minus 18. So what is the base function or the parent? The base is 3 to the power of x. And now let's talk about transformations. Two, that means we have a vertical stretch by factor of 2. That is one transformation, correct? The other one is vertical translation 18 units down. Perfect. Now clearly both are vertical translations, correct? So as far as the points are concerned, the image point I mean, so if x and y are the points on the parent function, in that case the x value will remain same, but the y value will get multiplied by 2 and then take away 18. Perfect. So what we need to do is to check the key points. As we discussed earlier, as far as the key points are concerned, we are looking into the horizontal asymptotes, right? So the horizontal asymptote is at y equals to 0. Now this value of y is changing, since now if original graph has a value xy, then the transformed graph has a value x 2 times y minus 18. So the y value 2 times 0 minus 18 will give you minus 18. So that becomes the horizontal asymptote. Perfect. So as we had sketched earlier, now quickly we'll just go through these steps. We now know that the horizontal asymptote should have been at minus 18. So this point here is minus 18. You can say y equals to minus 18 is your horizontal asymptote. Clear? Now, the other key points are y-intercept. The y-intercept is at 0, 1. The x value remains same, however the y value gets multiplied by 2 and minus 18. So it is 2 minus 18. So this point is actually equivalent to minus 16. So we get the y-intercept. Perfect. So we get the y-intercept. Now the other key point in this case, original graph does not have an x-intercept, and so we cannot really look into that. But now we look into when x is equals to 1, in that case the original function, which is 3 to the power of x, will be 3. Now in this particular case, at 1 you expect a value which is 2 times 3 minus 18. Perfect. So this value will be at 1, 18 negative from 6. So when you do that, you get minus 12. So at 1, we get a value which is minus 12. So further down. So at 1, we get minus 12. Perfect. So those will be good points to consider. And now connecting these, we could actually sketch a graph. We could also go in further to take a point which is at minus 1, the value will be 1 over 3. In that case, you can use the calculator and calculate the value at minus 1. It will be 2 over 3 minus 18. And so you get a value which is kind of there. So these couple of points can help you with the end behavior. And of course, when x approaches positive infinity, y will approach positive infinity. So that gives you the end behavior. So these key points can help you sketch the same graph which we did earlier using transformations. Perfect. So at times in examinations, you may be required to sketch the graph in different ways. Now here is the next question, which is exponential equation from the graph. So this time we are given the graph of the function and we need to find the equation of the function. So if you look at the graph, there are some critical points which you can observe. The y-intercept is at 2, x-intercept is at minus 1, and we have a horizontal asymptote which is y equals to 1. Correct? So these are the points given to us on the graph itself. Now since these are not very clear, we have written them in the description also. So let's look into the question. It says graph of the function y equals to minus a to the power of x plus b plus c has horizontal asymptote y equals to 1, x-intercept at x equals to minus 1, and the y-intercept at y equals to minus 2 as shown in the graph. Find the value of a, b, and c, right? So that is the question for you. I would like you to pause the video at this stage, answer the question, and then look into the suggestions. Okay, so let's begin by writing the equation itself, which is y equals to minus a to the power of x plus b plus c. Now c is directly related with horizontal asymptote, right? So the value of c, I will say value of c is right there. Why it is so? Well, if the value of x is approaching minus infinity, in that case, a to the power of x plus b will be kind of a to the power of minus infinity, which is approaching 0, right? And therefore, y will approach c. And in this case, y is equal to 1. And so we get the value of c as equal to 1. Is that clear to you? So all this calculation is required sometimes to get the value of c. In most of the cases, if the question is like given here, find the value of a, b, and c, we need not even do this calculation. Perfect. We may save our time and get it straight, right? So that is how we are going to get the value. Okay, now once we know c, let's rewrite the equation, which is y equals to minus a to the power of x plus b really means times, right? Plus, and c is 1 for us, correct? So we have written the same equation slightly in using the properties of exponents. Now let's look into each point one by one. It's a good idea to work with the y-intercept. Since x is 0, easy to work, right? So the y-intercept is at minus 2. That means the value of y is minus 2 when x is 0. So minus a to the power of 0 times a to the power of b plus 1. Do you see how easily we have separated them? That's the beauty which you need to appreciate when you're preparing for exams. How to make things simpler. And now we can say a to the power of 0 is 1. So basically what we get here is minus 2 equals to minus a to the power of b plus 1, or a to the power of b is equal to 1 plus 2, which is 3. So we get a to the power of b as equal to 3. Now let's look into the second point, which is the x-intercept where y is equal to 0. Okay, so we are looking at the x-intercept, and here y is equal to 0. The point, of course, is minus 1, 0. So when I substitute this point in this particular equation, what do I get? We are going to use the equation right here. Y is 0 for us, and minus a to the power of minus 1 times a to the power of b plus 1. So that gives you a fraction in the form a to the power of b over a, right? We're taking this to the left side, is equal to 1. And that clearly indicates that a to the power of b is equal to a. So that means that b is equal to 1. Clear? A to the power of b is a, that means b is 1, right? It is b equals to 1. So that is how you get the value of b. Once you have the value of b, you can substitute it here and get the value of a. So we get a, b is 1 is equal to 3, and that gives you the value of a as equal to 3. Is that clear to you? So we have all the three values a, b, and c. Now we can write down our answer, which is a is equal to 1, b is equal to 1, a is 3, b is 1, and c is 1. So that is how you're going to answer this question. I'd like you to look into this solution once again. See how easily we have found all the values. So remember one thing, that this c is directly related with horizontal asymptote. Perfect. Normally it was 0, but now it is translated up and down, so that is a direct relation. And as far as the exponent is considered, it's a good idea to write it using the exponential rules and then work out with the equations. It makes sense. Now let's take up the last example, which is based on modeling of exponential functions. So I hope you appreciate that in this particular video, we have considered the most important aspects of exponential functions. Now we have an excellent example. The question here is, eucalyptus trees were planted in California in early 1900s for timber as they grow fast. The height h in meters for this tree t years after planting is modeled by the equation h equals to 30 minus 28 times 0.8 to the power of t. What is the height of the tree when planted? Calculate the height of the tree after 2 years. What is the predicted maximum height of the tree? And sketch the graph of h against t. So it's a fairly simple question. I'd like you to pause the video and answer this question. So we have the equation h is equal to 30 minus 28 times 0.8 to the power of t. Part A. What is the height of the tree when planted? So that means when t equals to 0. Substitute t equals to 0. So what we get here is height will be equal to 30 minus 28, 0.8 to the power of 0. Anything to the power of 0 is 1. So we get this as 30 minus 28, which is 2. The units are meters, so we get height equals to 2 meters as our answer. Now let's look into part B, which is calculate the height of the tree after 2 years. So after 2 years, we'll have h equals to 30 minus 28 times 0.8 to the power of 2, which is 30 minus 28 times 0.8 to the power of 2 is 0.64, right? 64 divided by 100. So that is what you get. So you actually need a calculator at this stage. I didn't realize that. So you need to multiply 28 by 0.64 and then find the answer. So we have 28 times 0.64, which is 1792. So we get answer as 30 minus 17.92, and that is equal to 12.08. Approximately, you could write this as equal to 12.1. All right. So, it could be done without calculator also. It was not necessary. So here is the important step. Many times in the test paper, we are given that write the answer to 3 significant figures. So 20.1 is 3 significant figures, correct? So if it is mentioned, it should be written like this. Perfect. Okay. Now, part C is what is the predicted maximum height of the tree? So let's answer part C also, which is maximum height. So as you can see, in this particular equation, what happens when t is approaching infinitely large value? In that case, 0.8, it is less than 1, right? To the power of infinity will approach 0. And therefore, we get the height will be approaching 30. So that gives you the answer that the maximum height is going to be 30 meters. Correct? So that is how you could actually answer this particular question. So these are the answers for A, B, and C. Now we can actually sketch the graph. Let's sketch the graph on a fresh page. So we got 12.1 as the answer for after 2 years, right? So we'll put these values and then sketch the graph. So we just calculated some of the values. So what is the height of the tree when planted? It was 2 meters, right? The second one was 12.1 meters, and the last one was 30, of course. The function given to us is h equals to 30 minus 28 times 0.8 to the power of t, right? Now, to sketch the graph, let us say, let's sketch it here now. We have, it is approaching 30, right? That is the maximum height, and it starts with 2. So that is the starting point, correct? So you can write, or rather draw, a horizontal asymptote y equals to 30. That is what it means, right? And the graph of the tree starts from 2 and it kind of approaches. This point is critical, which is 2. Clear? So that is how you could actually sketch a graph. Now, there are some important values which you could place. One of them we just calculated, which is, let's say, so at 2, we have a value which is approximately 12. This is height in meters, and we have time t in years since planted. Perfect. So that is the graph of height against time, where time t is since it was planted, right? Now, to get some more values, I'd like you to make a table so that for different times you calculate the height, right? So you could write 1 here, for example, and then 2, we know. You can have 5, 10, and that will help you to get some more points on the graph to get fairly accurate graph in this particular case. Perfect. So that is how you should be actually doing this particular question. I hope the steps are clear. So I'll move on and take up the next topic, which is logarithmic functions. We'll actually begin with logarithmic functions in the next video. Here is the question for you to think about, which is same question. Eucalyptus trees were planted in California in year 1900 for timber as they grow fast. The height age of in meters of this tree t years after planting is modeled by the equation, same equation, h equals to 30 minus 28 times 0.8 to the power of t. But this time the question is, when will the tree grow taller than 75% of its maximum expected height? So that is the type of question which we need to now answer. So we are saying that height is given as 30 minus 28 0.8 to the power of t. Now, we are given the height. The question is find t. We are given the height and the question is to find t. How are you going to do it? So we have to do some reverse calculation, correct? And that recalls for inverse function. Logarithm is inverse function to exponential functions. That is the connection. And we'll look into this connection and solve this question in our next video. I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. So within this particular video, we have actually discussed all these points. We now understand all the characteristics of exponential functions. We also understand how to work with an exponential equation, how to relate transformations and then sketch its graph, also how to write equation from the graph, and we took a very simple model on exponential functions. We'll get into more details of modeling in later half of our videos. So once we learn about logarithmic functions, then we'll look into ln, e to the power of x, and natural log, and then take some very good examples on modeling. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.